Hello students, today now we are going to discuss some more problems about Thevenin's theorem. So previous class already I told you if there is a problem given how to find out the current flow through a particular value of the load resistance. So in Thevenin's theorem, so there are some procedures already I told you, and it is one of the problem. So there is a complex Z1, Z2, Z3 and ZL. So in this problem, find the current through the ZL using Thevenin's theorem. This is an load ZL impedance here. So there is a rectangular coordinate, another one is a polar form. So in your AC, so one is your rectangular component, how to convert a rectangular component into polar components. So this is your Z1, Z2, Z3 and ZL. Now we are going to calculate the current, how much current flow through this terminal. Let this terminal is your A and is your B. So now we are going to calculate what amount of current flow through the load impedance, that is your ZL. So solution, what we will do first of all, the current, now we are going to calculate what amount of current flow through this load resistance. Simply we have to disconnect it. If we disconnect it, in first step we have to disconnect ZL, disconnect ZL, and your circuit is like this. So simply this is your Z1 and this is your Z2, then this is your voltage, source voltage here like this, and here there is your Z3, simply so like this one. Okay, so in this, if we disconnect the load resistance or load impedance, we have to calculate your Thevenin's voltage VTH or open circuit voltage VTH or VOC. So how to calculate VTH or VOC? So since there is a open terminal, there is no current flow through the ZL, Z3. Simply we have to calculate what amount of current flow through this branch here like this. Once you got the current, this is your Z1, this is your 8 plus J8. If you convert into polar form, one is your what? Magnitude, another one is your angle. So how to get this one? Because in rectangle, if you convert rectangular to polar, so this is nothing but what? In rectangular to polar, like this. This is your real axis and this is your imaginary axis, like this. So this is your 8 and this is also 8, and you are going to calculate this value, and this value is nothing but what? This square plus this square root over, that it becomes 11.3, and angle is nothing but tan inverse tan theta p by v, this by this. So tan 1 is equal to 45 degree. So this is your 8 and this is your 8 by 8 1. So tan theta equal to 1 or theta equal to tan inverse 1, that is your 45. So 8 plus j8 can be converted into 11.3 angle 45 degree. Similarly 8 minus j8, same magnitude will be same, and angle will be what? Tan inverse of minus theta equal to minus tan theta, that's why it is minus 45. So how to get current? Simply this, since this is open terminal, there is no current flow through the Z3. So only the current flow through this loop. So I. So value of I, current is how much? The value of I is nothing but what? Voltage, simple circuit. Voltage is your 10 divided by Z1 plus Z2. Z1 plus Z2. Here this is your 10 angle 0, Z1 plus Z2. Here Z1 is your 8 plus J8 and Z2 is your 8 minus J8. If you add this 8 plus J8 plus 8 minus J8, this will be cancelled out. So 8 plus 8 16, so that is your 10 by 16. 10 by 16. Okay, this is your I, and this voltage is nothing but VTH or VOC. So I into Z2. So VTH equal to your VTH or VOC, VTH or VOC equal to, so I into Z2. The value of I is your 10 by 16 and Z2 is your 8 minus J8. So 8 minus J8 is nothing but 11.3 angle minus 45. So 10 by 16, it is around what? 10 by 16, the value is your 10 divided by 16, it becomes what? 0.625. So 0.625 ampere, and VTH equal to, this is your I, 0.625 into Z2, here angle is your 11.3 into 11.3 angle minus 45, and the value becomes what? 0.625 into 11.3, the value is your 7 angle what? That is your minus 45. Since this is 0.625, the angle is nothing but 0. So if you multiply 2, 1 is, and this can be added. So 0.625 into 11.3, it becomes 7 angle 45. Then this is your VTH or VOC. Then calculate RTH. To calculate Thevenin's resistance, RTH. How to calculate RTH? To calculate RTH, the voltage source should be short circuited, and here this voltage source should be short circuited, and this will be short circuited, and this is your what? Same Z1, and here same Z2, here then Z3. This is nothing but your Z3. We have to calculate the RTH. The value of RTH is how much? Z1 parallel to Z2 plus Z3. The RTH, so RTH or Thevenin's resistance equal to Z1 parallel Z2 and series with Z3 plus Z3 plus Z3 plus Z3. If Z1 parallel Z2, Z1 is how much? 8 plus J8 is your 11.3, and another one is your also 11.3. So 8 plus J8 parallel to 8 minus J8, and in this way you can calculate Z1 Z2, and this is your what? 11.3 into 11.3, and this is your 11.3 into 11.3 equal to 127.69 divided by 11.3 plus 11.3 is your 22.6 divided by 22.6. The value is your how much? 5.65, and this is your, if you will consider the magnitude part, and this is your 5.65 plus Z3. Z3 value is your how much? 2 plus J20. If 2 plus J20, if we will convert it into polar form, the value will be how much here? The 2 plus J20, the value will be how much? So that is your 4 plus 400. So root over of 404, that is your 20 point something. So this is your around 20 point something, and tan inverse 20 by 2, 10. So tan inverse 10 angle is like this. So if you will consider the magnitude part, this is your suppose 20, if you will consider 20.08 something, and this value becomes what? That is your 5.665 plus 20, it is around 25.65. This is your 25.65. This is your RTH. Then you can calculate, that is your what? Then reconstruct the circuit. This is your VTH. So VTH is your how much? So VTH equal to 7 angle minus 45. Since 7 angle 45, here this value is your, this is your VTH, 7 angle minus 45, then RTH the RTH is around 25.65. Then connect the ZL, this is your ZL, and you can find out the current flow through this load impedance ZL, and this is nothing but what? This is your minus J10, serial part is 0, and the magnitude will be same thing, 10 angle what? That is your 0. So current flow through this impedance is how much? Voltage 7 divided by this plus this. In this way you can calculate the current flow through this load impedance ZL by using Thevenin's theorem. So next, another question, that is in this figure, the problem given, using Norton's theorem find the current flow through the 10 ohm resistor. Already I told you. So in using Norton's theorem, we have already been discussed some different types of problems. Now today, so this type of problem is asked to find out what amount of current flow through this 10 ohm resistor by using Norton's theorem. What we will do in Norton's theorem? What we will do in step 1? Norton's theorem, how to calculate current flow through the 10 ohm resistor using Norton's theorem. Like in your Thevenin's theorem, generally we are going to calculate that is your Thevenin's voltage and Thevenin's resistance. In case of Norton's theorem, same procedure. In previous case, in Norton's theorem, simply you disconnect the load resistance, but here you will short circuit that resistance and find out the short circuit current, means what amount of current flow to this branch. If you will rerun the circuit, but the figure is like this, that is your here, this is your 20 volt and this is your 2 ohm and this is your 8 ohm, this is your 12 volt. Simply short circuited this branch load resistance, short circuited this branch and calculate the short circuit current ISC or Norton's current, ISC or IN, Norton's current. Okay, and this is your 2 ohm, this is your 2 ohm and this is your 5 ohm. Okay, now we are going to calculate what amount of current flow through this branch. Already this 10 ohm resistor, we have simply short circuited this branch and calculate the short circuit current or Norton's current. So it is a very easy, already I told you, Maxwell's loop analysis simply, and this is one loop and this is another loop. Suppose this loop current I1 and this loop current what? That is your I2. So I2 means what? This is in series, means what? What the value of IC, ISC or IN is nothing but I2. So directly using Maxwell's loop analysis, we will calculate I2. That value of I2 is nothing but short circuit current or Norton's current. So first of all, this is since it is a two loop, so there is your 2 into 2 matrix will form. So already I told you in Maxwell's loop analysis, so there is your resistance matrix into current matrix is nothing but what? That is your voltage matrix. R11, R12, R21, R22. First loop, R11 means sum of the resistance formed by the loop 1. In loop 1, how many number of resistance? 5 plus 2, that is your 7. R11 is your 7. Then R12 is your the resistance common between 1 and 2. There is only 2 ohm resistance is common, so that is your minus 2. Common, put the minus sign. Similarly, R21, 1 to 1 is same, that is your minus 2. The resistance common between loop 1 and loop 2. R22, sum of the resistance formed by the loop 2, that is your 8 plus 2, that is your 10. So this is nothing but resistance matrix. Then current matrix, that is your I1 and I2. Then voltage, first loop voltage, that is your 20 volt. So 20 volt, if the current direction, the voltage direction from minus to plus is plus. So here the direction of current I1 is same as this voltage direction, that will be plus. So that's why in place of voltage V1 you can write 20. Similarly, the voltage direction from minus to plus is plus, the direction is like this. So if you observe, this loop current I2 is same as this voltage direction, so that will be in place of V2 you will put what? 12. So once resistance matrix into current matrix and voltage matrix is formed, R into I equal to V, then our intention is to calculate the loop current I2, because the short circuit current ISC is same as IN. So directly we will calculate I2 or IC. So how to calculate ISC or IN, ISC or IN or I2? By using what? By Cramer's rule. Here, by using Cramer's rule, we will calculate the value of I2. The value of I2 is how much? Using Cramer's rule, I2 equal to, simply you close the second column, that is your 7 minus 2, 7, that is your 7 this is your 7 minus 2, then 20, 12, this matrix divided by delta. Delta is nothing but the resistance matrix, value of resistance matrix. So delta value is how much here? So delta, if you calculate the value of resistance matrix here, this is nothing but is your delta. 10 into 7, that is your 70, minus or resistance matrix R, value is how much? 70 minus plus minus minus, that is your 4. This is nothing but 66. So this value is nothing but 66, and this value is how much? 12 into 7, 84, minus plus 40, divided by delta is nothing but 66, and the I2 value is how much here? That is your 4, 124. If you add this 124 divided by 66, and it will be around, by using calculator, that is your 124 divided by 66, the value will be 1.87, that is your 1.87 ampere. So that is your ISC or IN, short circuit current ISC, equal to 1.87 ampere, which is nothing but your Norton's current. So ISC, once you got ISC, then we are going to calculate, that is your Thevenin's resistance. How to calculate Thevenin's resistance? In Thevenin's resistance, what procedure we have followed in Thevenin's theorem? Exactly same procedure we will follow, how to calculate Thevenin's resistance. So in Thevenin's resistance, generally all the voltage source should be short circuited and current source should be open circuited here. So voltage source should be short circuited and current source should be open circuited. Here there is a 20 volt source, it will be short circuited, and here this is also short circuited. And to find RTH, what will do? The voltage source, this is your 20 volt source, this will be short circuited, and this is your 5 ohm, and then this is your 2, this is your 5, this is your 2, then this is your 8, and this 12 volt source would be short circuited here like this. This is short circuited, this is short circuited, and this is short circuited. So that is your, to find RTH, this 5 ohm resistor parallel with 2 ohm resistor and parallel with what? 8 ohm resistor. So RTH equal to 5 parallel to, if the two resistance are parallel, equivalent resistance is your product of the resistance by sum of the resistance. So that is your 5 into 2 by 5 plus 2, 10 by 7, plus here that is your 8, and this is nothing but what? So what? So the value will be how much? 8. That is your 10 by 7 plus 8. 10 by 7 10 divided by 7 equal to 1.4285. Okay, this is your RTH. This is your 5 ohm parallel to 2 ohm. Then plus 10 divided by 7, but then plus 8, the value is your 9.42, that is your 9.428 ohm. This is your RTH. Then what will do? Then calculate the short circuit current or Norton's current. Okay, so then in Norton's equivalent circuit, draw Norton's equivalent circuit. Norton's equivalent circuit. Already we got ISC, Norton's current, ISC, then RTH, Thevenin's resistance, then RL or load resistance. This is your A, this is your B. Okay, so then find out the IL, not what amount of current flow to the resistance RL. So ISC, in previous slide, ISC equal 1.87, and this is your 10 ohm and this is your 9.428. So that is your 1 and this is your 1.87, this is your 1.87 ampere, and this is your 9.428 ohm, and this is your 10 ohm. So what amount of current flow to the 10 ohm resistor? Simply you can apply the current division rule. What amount of current flow to this resistance? That is your total current into opposite resistance by sum of the resistance. So IL, the current flow to the 10 ohm resistance, IL equal to, that is your ISC or IN, ISC or IN. We can say that short circuit current or Norton's current, IN opposite resistance, that is your RTH, divided by RTH plus RL. So IN equal to, that is your 1.87 into RTH, that is your 9.428 by, that is your 9.428 plus RL is your 10. So the value is your what? 1.87 into 9.428 divided by 19.428, and the value will be how much? By using calculator, that is your 1.87 into 9.428, the value is your, that is your 17.63 divided by 19.428. This divided by 19.428, the value is your 0.9, and the value is your 0.9 ampere. Okay, so in this way we will calculate the current flow to the 10 ohm resistor by using Norton's theorem. So next class we will follow more and more number of problems using Thevenin's and Norton's theorem. So already we have discussed the different varieties of problems using Thevenin's theorem and Norton's theorem. So today we will now stop now. The next class we will again meet again and we will do more and more number of problems. Thank you.